Okay, good morning. Today we're going to look at quadratic simultaneous equations. We're going to go through how to solve them and find, you will get two pairs of solutions. So an x and y in one pair and an x and y in another pair. It's different to linear simultaneous equations in that you can't solve them by elimination, so you can't make x the same or y the same and add or subtract your equations together. It's not quite as simple as that for a quadratic because you have that squared in there. It makes it more difficult, so you can't eliminate one. So we need to use substitution to be able to solve it. Now, it's easier when a question is like this and they're both y equals, because we can just take this y equals x plus 1 and replace the y in the first equation with x plus 1. And then we rearrange and we solve to find the two values of x. So I'm going to rewrite it like that. So I've got x plus 1 equals x squared minus 3x plus 4. Okay? Then we rearrange it to make it equal to 0. It's a quadratic because we have a squared in it, so it has to be equal to 0 for us to be able to solve it. So I'm going to subtract, I use a different colour to show what I'm doing. Subtract the x and subtract the 1 from both sides. Okay, so we get, stick with the same colour, x squared minus 3x minus 1x is minus 4x. And then 4 minus 1 is positive 3, so plus 3. So this is our equation now. We need to factorise it to be able to solve. So two numbers that multiply to make 3 and add to make negative 4. They would be x minus 3 and x minus 1. It's still equal to 0. We would solve each bracket, put it equal to 0 and solve it. So x minus 3 equals 0 means x has to be 3. And x minus 1 equal to 0 means x has to be 1. Then we use those solutions, okay, and again we substitute both of them one at a time into one of these equations. The linear one, the one without any squared, is always going to be easier. So I'm going to write when x equals 3, and I'm going to substitute x equals 3 into y equals x plus 1. So when x equals 3, y equals 3 plus 1, because I'm removing the x and replacing it with 3. So y equals 4. So those are your two solutions, x equals 3, y equals 4. And then when x equals 1, I'm going to do the same thing again, y equals 1 plus 1, because I've replaced x with 1 this time, and we get 2. So again, that is our second solution. So we have two pairs of x and y's, so you have to be careful to keep them in the correct pair as well. So that's why I wrote this when. So when x equals 3, y has to be 4. When x is 1, y has to be 2. It doesn't work the other way around. We can't have x equals 3 and y equals 2 happening at the same time. They have to be in their correct pairs. So make that really clear when you are writing your answers. You could just write them next to each other. You could use arrows. So when you've got x equals 3 here, you could put an arrow down to show that y equals 4 at the same time, but make it really, really clear that which x goes with which y, okay? Right, this question is slightly more difficult, so only because our linear equation isn't y equals and neither is this one, so we can't just put them straight equal to each other. We need to rearrange the linear one, always the linear one. You wouldn't try and rearrange the quadratic. So rearrange the linear equation until it's either x equals something or y equals something. So we're going to make it x equals 2 minus 2y by subtracting that 2y from both sides. Okay, now that it's x equals, we can substitute it into the quadratic. So wherever there is an x, which is here, we're going to replace it with 2 minus 2y. So I have 2 minus 2y, and it's squared because x is squared here, plus y squared equals 17. I'm going to expand that bracket. I'm going to do it over here out of the way. So I'm expanding it like this. 2 times 2 is 4. 2 times minus 2y is minus 4y. Minus 2y times 2 is minus 4y, and then minus 2y times minus 2y makes positive 4y squared. So I'm going to replace this bracket now with this, if I'm going to simplify that first, so I get 4 minus 8y plus 4y squared. I'm going to replace that bracket now with the expanded form, so I have 4 minus 8y plus 4y squared plus y squared. Okay, don't forget that we had this y squared here. That's a really common mistake, is that people forget that it's there. That's equal to 17. We need to rearrange that so that it's a quadratic we can actually solve. So I have 5y squared all together. I'm going to put that at the front. I have minus 8y, and at the same time I'm going to subtract this 17 from both sides. So I get 4 minus 17 is negative 13. And now it's equal to 0, so we can solve it. It is a more difficult one to factorize because of this 5. So first we need to multiply the 5 by the negative 13, which is negative, I'm going to do it on my calculator, 65. Negative 65, and then we need them to add to make negative 8. So two numbers that add to make negative 8 and multiply to make negative 65. I'm going to use 8 and 13, I think. No, I'm not. 5 and 13. Yeah, 5 and 13. Negative 13, yeah, and positive 5. So I'm going to split my 8y up into minus 13y and positive 5y minus 13 equals 0, and then factorize each half. So I'm going to take only y out of the first part, so I get 5y minus 13, and then the second one I'm only going to take out 1. The only factor they have in common is 1, and then in the bracket I have 5y minus 13 equals 0. Put it into their separate brackets. Y plus 1 and 5y minus 13 are equal to 0, so y is negative 1. This one's a little bit more complicated, so put it equal to 0 if that helps you. So we're going to add 13 across and then divide by 5. Y equals 13 over 5. We run out of room there. So now we need to find the x. So I'm going to use the linear equation. I'm going to use this one, and I'm going to put the y's, the two y's that we found. So when y equals negative 1, I'm using this form because it's already x equals 2 minus 2 times negative 1. So that's 2 minus minus 2, which is plus, so it equals 4. When y equals 13 over 5, x equals 2 minus 2 lots of 13 over 5. I'm going to just do that on my calculator. So 2 times 13 over 5 is 26 over 5, and then I'm doing 2 minus that. So I get negative 16 over 5. Okay, I've literally just typed that into my calculator. And those are my two solutions. I'll highlight that so you can see them a bit more clearly. Okay, so when y is negative 1, x is 4, and when y is 13 over 5, x is negative 16 over 5. Okay, one last example. And again, the clue, just like when you're doing normal quadratics, the clues in the question give your solutions to 3 significant figures. So that means you are going to have to use the quadratic formula to solve it. So start the same way, make your linear equation either x equals or y equals. Y equals is going to be the easiest here, so I'm going to subtract 2x from both sides, so I get y equals 1 minus 2x, and then I'm going to substitute that into the first equation. So I'm going to take y out and replace it with 1 minus 2x. So my equation becomes x squared, okay, because remember we still got this, don't forget that that's there, plus 1 minus 2x all squared, and that's equal to 7. I need to expand the bracket, so 1 minus 2x times 1 minus 2x becomes 1 times 1 is 1. 1 times minus 2x is negative 2x. Negative 2x times 1 is still negative 2x. And the negative 2x times negative 2x is positive 4x squared. And we simplify it, so I get 1 minus 2 is minus 4x plus 4x squared. I'm going to replace this bracket now with our simplified form, and I'm not going to forget this x squared, okay? It's still there. So I have x squared plus 1 minus 4x plus 4x squared equals 7. Simplify and rearrange, so I'm going to move this 7 over at the same time as I simplify. So I have x squared plus 4x squared makes 5x squared. I have minus 4x, and then I have 1 minus 7 is minus 6 is equal to 0. I know it's not going to factorize because my question says to give it to 3 significant figures, so I'm going to use the quadratic formula. A is 5, B is negative 4, and C is negative 6. So I'm going to put that into the formula. Remember, the formula is, if I write it up here, x equals minus b plus or minus the square root of b squared minus 4ac, and then it's all divided by 2a. So minus b is already negative, so minus b becomes positive b, so it's just 4 plus or minus the square root of b squared, negative 4 squared is 16, minus 4 times 5 times negative 6. And then that is all divided by 2 lots of a, so it's all divided by 10. Simplify where you can, so you get 4 plus or minus the square root of 16 minus, in fact it's not going to be minus because it's going to be minus here, minus there, together makes a plus. And then 4 times 5 is 20, times 6 is 120. It's still divided by 10, so it's 4 plus or minus the square root of 136 over 10. So x equals, do it once with the plus, so 4 plus root 136 is divided by 10 is 1.5, 3 significant figures, 1.57, and or x equals 4 minus the square root of 136 divided by 10 is negative 0.766 to 3 significant figures. So then find the y's. So when x is 1.57, y is 1 minus 2 times 1.57, which again I'm just going to type it straight in my calculator. Use a bracket around the multiplication to make sure you don't get any funny answers, but you get y is negative 2.14. And then do it again. I'm running out of space, we're going to put it up here. When x is negative 0.766, y is 1 minus 2 lots of negative 0.766. And again, just put that straight into your calculator. Use a bracket. Don't forget that it's negative 0.766 is 2.53 to 3 significant figures. So those are your solutions. And when x is, y is. Okay? Again, keep them together. Keep it really clear which x goes with which y to make sure you get the correct marks. And that's it. Hope that helped. Hope it makes sense. I know I've gone through it quite quickly. But just keep following those. There's 3 different types there. So one's where you just have them both y equals, so they're easy to put equal to each other. One where you have to rearrange the linear one to make it either x equals or y equals, and then substitute that in, but we're still factorizing. And then one where you have to use the quadratic formula. Hope that helped. Thanks for watching.